Good afternoon, everyone, and welcome to day 3 of ACI-Ontario's fall webinar seminars. If you've been joining us the last 2 days, welcome back. Today, we're bringing you our third and final presentation titled Updating Canadian Concrete Standards to Avoid Slab Rejection. And joining us is Lloyd Keller. A quick bio before we get started. Lloyd Keller joined EllisDon in 1986 and has 32 years of experience overseeing the technical aspects of major projects. As EllisDon's Director of Quality Assurance and R&D, Lloyd works closely with engineers to validate the constructability and technical requirements of major projects, while developing and implementing a subcontractor-based quality assurance system for EllisDon. Heading up the R&D division includes providing engineering support and guidance for EllisDon projects, with particular focus on building science and concrete materials and construction-related issues. Lloyd's past experience in Malaysia and the Bahamas involved the identification, procurement, and testing of concrete materials, resulting in the development of performance mix designs that produce high-strength concrete in excess of 100 MPa for the Kuala Lumpur City Centre and 160,000 yards of concrete for Atlantis at Paradise Island. Lloyd's extensive knowledge and experience makes him an asset to any job. And with that, I'll open it up to Lloyd.
Okay. Good afternoon, everyone, and hopefully you're going to enjoy this presentation. This is basically it's an update of what we've been doing, and as just a little bit more introduction, I'm actually the chairperson for Subcommittee 6 at CSA, which is in formwork, pre-stressing, reinforcing, and tolerances for the standard. I'm also chairperson of ACI 134, which is constructability, and past secretary of ACI 237, which is self-consolidating concrete. Anyways, so let's get on with what we're going to talk about today, which is what you see on the screen. Okay, so what we're going to be talking about is a lot of it is what's evolved with our annex. We're building a new annex for the standard, and I'm going to describe what's incorporated within that part of the annex. Let me describe just quickly just the differences between annexes and standards, and for those that may or may not know. So essentially, an annex is to provide a commentary or an explanation for provisions given in a standard. A standard uses the typical standard speak, thou shall, thou will, thou hast to. The annex is basically its guidance for the suppliers. The annex is intended to provide limits on what materials may be classified and how to use materials, but it's a benefit for the user to get an understanding of the topic and to get some guidance as to what's happening. But it is not mandatory, and therefore it's different than a standard. A standard, you're limited to what you can say and what you can do and how you can express. So hopefully everyone gets the difference between the two standards, the two different publications. Over the last few years, actually, CSA rather, has been publishing a number of annexes, basically because of their benefit to being explanatory and setting commentaries to ensure that people understand what's happening and get a good understanding rather than just thou shalt. It gives them the ability to understand things. So we have last standard, both the ultra high performance concrete and mass concrete were published as new annexes. So Annex U and Annex T. The current edition annex plan has 50 pages of informative guidance developed by a diverse group of industry professionals who are involved stakeholders in the design, construction, and supply of materials for elevated slab elements. We have some 12 members on our committee, of which there's people from the design group, RJC and Stevenson's. We have people from the reinforcing steel groups. We have people from the formwork side. We have people from the general construction side, like ourselves, and the testing and acknowledging side also. So we've developed a diverse group of people to make sure that, in fact, we have the typical elements we're looking for. The title of our annex, we don't have a number yet because it depends on, we have to look at the publication process and what's all being put in place before we can get an exact annex, but it's Annex XXX. And essentially the topic is elevated slabs and building construction best practices. Again, our committee structure on who we are and the members and the 12 members that are partaking. I'm again the chairperson of Annex of Chapter 6, so it's under my surveillance, the making up of the committee. Whenever you're doing something this, CSA requires that there's a rationale as to why do we need this annex? Well, I'm not going to read all the fine print that you can see on the left side of your screen, but the highlights are there's 30 years of experience from my perspective in working with these standards has demonstrated the need for a thorough commentary on elevated slabs. Dynamic movements or flexures after load transfer impact the as-cast geometry significantly, and we need to explain what those are, why those happen, and the effects of that on the surface profile that the subsequent trades will come on, and they've got to build their product on top of something that's already been cast. The other thing is in the contracting process that we have in our system, it's multidiscipline responsibilities from all the various subtrades, from the designer, from the architect, from the general contractor, whatever else, all have a piece in the performance of the ultimate as-cast element. But the way of contracting really doesn't put a combined responsibility. So each one has their own different silo that they have to meet or achieve, but the linkage isn't there to ensure that one process or procedure or methodology transfers appropriately to give the next subsequent trade what they need to do their work. And so that's something that's missing. So we explain a lot of the process, what's going on there. So what we have is the annex is supplying a best practices document that provides guidance for a holistic approach towards effective construction and coordination strategies that hopefully deal with this disparity between the individual contract sections. You probably can't read it all, but the general structure of our annex, and that's the 50 pages, table of contents shows topics for discussion in the annex. One is an introduction, and then there's shoring and falsework systems, placing, finishing, and curing, techniques for stripping, shoring, and reshoring, profile measurements, methods and benefits, and shortfalls. There's techniques and practices for reinforcing and support, design specifications, process and sensitivity of conventional approaches to prediction of response for movement. There's measuring in situ properties of the materials, There's a section on case studies that were developed from some sessions in Denver ACI, which was some 2 or 3 years ago, which had a coordinated effort of a number of presentations, which is about 8 presentations, all showing the performance results and the benefits and the learning that was developed on having a coordinated effort at the pre-construction stage and carrying it through to see what we could do to control the movements of elevated slabs, and it gave some very good backup on that. And then finally, in 9, there's the reference documents that we use to talk about that will be our reference in the general annex. So that's the general structure of how it's set up. Some examples. Okay. Formwork Systems it starts out. So this is an example, but we go through a whole bunch of the different elemental formwork systems that are used typically in elevated slab construction. And here's an example of one for handset and one for flying truss panel. And what you can see, there's a drawing that shows the makeup of the system and how it's put together. And there's also descriptions of the elemental assembly components and a commentary on benefits for construction, limitations for setting control, and typically variations from a planar uniformity for planar uniformity based on the type of system. So each one has its own benefits and its own disadvantages. So we're explaining all that. Some are very elemental in construction, where you have many pieces, and others are modularized, like the flying truss panels, where you do half a bay of a slab or whatever is basically supported by one of these trusses. So it gives you a perspective on that. We describe all that. There's another section that describes the methods used for determination of the final as-cast profile of the finished concrete surface prior to the concrete setting. And so it shows different methods for measuring, which typically what you do is you follow the profile of the elevated form using a probe or a stick that will measure the thickness of the concrete. So you follow along the profile of the form and ensure that you get a consistent measurement. You can't use a laser level or whatever, because in most cases these elevated slabs are cambered or purposely curved to accommodate the movement that's going to happen once you release the forms and you transfer the load into the elevated slab element. And there's a picture of a double rider float and system that's used in some of these things. Benefit of this, of course, is once you put pan floats, which are like a large, a lot of the trades guys call it a pizza pan, in place of the floats or the trowel blades, and with that wide axis that you can see there, you basically are impacting an area of about 6 to 8 feet, and you get a lot more uniform surface than if you use just a single pull behind type piece of equipment. The pizza pan, again, is a lot flatter surface, so it's a benefit to getting a flatter surface that you're going to evolve into. And again, some pictures of a flooring system, the finish, the area that's finished, and then the repercussions of what can happen if, in fact, you have problems with the adhesive of the material binding between the floor covering and the slab surface. And there's many different reasons why this happened, but it's all included in the annex. There's also extensive sections that we've developed and built in here that summarize the importance of curing and protection. They set suggestions for methods and a quality plan to implement an effective curing regime, taking into account variations in climatic or ambient weather cycles. One of the things that it's typically not done in a lot of cases in elevated slabs in conventional high-rise buildings, but it is to the detriment, because one of the key things that happens if you don't cure is you and probably a lot of you know that, is you affect the ability of the concrete in the cure affected zone, and that's the top quarter to eighth inch of the surface, to fully hydrate it. Because if there's no water, the surface doesn't hydrate. You get incomplete formation of the cement molecule, and you end up with a phenomena that's called dusting, which is basically under wear. These unhydrated pieces just become crumble and then develop into a dust on the top surface. And I was just at one of our projects we did last year, just finished, and we were looking at some of the stair treads that went up into the top of the building and everything, and I could see the effect of not curing, because there was dusting throughout the whole staircase. And I know when I went with the former guy, when he was asking me what was happening, he was a bit surprised that it had that effect. And then I showed him by scratching just easily the surface and how weak and friable it was and how this impacted. So that's something that we've got a fair amount of information. It's quite extensive now, and I don't think there's an awful lot that you will find in typical literature to talk about the importance and why it's important and what some of your procedures might be to facilitate. There are options if you do have a problem where you can add things like topical coatings that will try to combine the unhydrated products into a coalescence of like a sodium silicate or a sealer type material. Best practices for controlling movements due to creep, shrinkage, and deflection. How should measurements be made? Quality control processes to measure the movements and implement cause and effect adjustments to the procedures being implemented. So this is a section on controls for stripping, shoring, and reshoring. Just a picture on which is pretty graphical here, but it shows what movements happen on concrete slabs, especially after load transfer and pre-design for the camber to supposedly, once you release the supports, the intent is that in fact you will get a flat surface because of the dead load being transferred now into the slab itself. But we all know that that doesn't happen the way it needs to be, and so we describe a bunch of processes to try to control that in effect once we are building the project. We talk about the point cloud survey, which is a highly effective means to measure the top surface of the element. And you basically, if you haven't seen it before, it spreads. It's a laser scanning system where you got literally thousands of points that are measured on the surface. It's then the information is collected and then processed through proprietary software that then gives you a heat map, which shows contours of the various elevations, and you can see from usually blue is low and red is high, and it gives you the ability to be able to assess what the impacts of the various processes that you've gone through, whether it be placing, finishing, stripping, curing. It shows the effect, cause and effect on what's happening. So it's a very useful way. It's a process that's accurate enough within 2 to 3 millimeters of what the actual is. It can be done in the process of about 2 hours. You can basically do a point cloud survey of any floor that you cast. And then if you've got, you can process it during the night and then point out to the people that did the work afterwards and just give cause and effect essentially within a day or so of what the effects of your processes were. So it gives you a real great way of measuring, seeing, and then you can also allocate modifications to your strategies to try to reduce the effect of what some of the considerations were, because you have a picture right away that you can look at. And that's just usually there's a number of different proprietary scanners, but there's a picture of a guy doing the point cloud survey and measuring the characteristics. And this is typically what you get. And there's the heat map that I described. So typically what happens, anything that's it's a sliding scale. It goes from red down to purple. Red is high and purple is low. So you see the effects of whatever the processes were very quickly and intuitively. You can see that this can be used by everyone involved in the project. And again, the accuracy to this, the isotherms around the perimeter of the heat map elements usually are within 1 to 2 millimeters is the gradients. So it's very accurate in giving you what you need. And this is all that's needed by either the formwork placer. We can superimpose an F number scale if we need be onto this, and that can also be shown. But also for the finisher, for the applied flooring installer, that's the kind of accuracy that he needs to be able to apply his flooring, and he'll know areas where he has to remediate or finish or cut and fill or whatever else to make it so in fact he can install his flooring, which is typically within an 1/8 to 3/16 of an inch if you measure a conventional straight edge gap. And that's what the flooring people use. They use a straight edge to measure. They do not use F numbers because and so what they'll do is they'll span between bumps and dips, and then once they've got a gap, then they know that they have to cut and fill. If, for example, around this area here, they're gonna have to grind that down or fill in between, and then they'll move it again and again and again, all the areas. So they make up all these little areas where they'll highlight, and then they've got to treat and fill. Whereas with the point cloud survey, they don't need to do this exercise, which is beneficial, and it also helps them. That's a very tedious, long time procedure that needs to be done, and it saves them a lot of time and effort, and it gives them the whole picture, but it gives us the picture too if we're the constructor, what's going on, and we can look to try to remediate things if they are going out of whack. There's also the section on reinforcing. We talk a lot about the reinforcing type, the location, and the means to support. Now, we have a fair amount where we talk about welded wire mesh also. And again, when you think of it, welded wire mesh is just a modular form of reinforcing steel, because it's everything in a modular panel that you place down and then support. And it saves time and effort, obviously, with the traditional placing of the reinforcing steel. Probably a lot of people aren't aware that with given enough time and procurement planning, you can get all kinds of different sizes of wire or steel members and spacing, so that you can customize to match what your requirements are. And then based on the type of the size of the wire or the mesh, then the supports underneath will vary, because obviously with a thicker, more robust wire, you don't need to support it as closely. Whereas with a very thin wire, like a traditional 6x6, 6/6, you need to support it very, very closely together. And it's not very effective really in the end of the world of achieving what we're requiring. And it's very difficult to make work. But there are lots of other sizes that do work, and they have the robustness to be able to support a guy from walking. And the spacing, the report of the supports is muchly increased to the point where it becomes a practical means to do that. And this is a we talk about for reinforcing steel. There's a sequence of placing bar supports and bars, and a bunch of diagrams that we've got some of our guys from the Reinforcing Steel Institutes to supply to us, and these are new, evolving. You'll probably see them in Reinforced Steel Institute of Ontario eventually, but this is state-of-the-art stuff as we're evolving. So it's good information, and it's entirely up to date. So it's beneficial from that perspective. So it gives us the spacing that we need to have versus the size of the element that or the wire or the bars that we're using. There's a big section on design and specifications. So we've had a couple of our one of the fellows from RJC and another from Stevenson's have spent a lot of time writing up what's happening in the design side. So it's a look into the world of the designer. What are the critical variables that they use in prediction of plastic elastic movements that happen after load transfer and construction loading? How do these movements impact the subsequent floor covering, exterior cladding, and what is the sensitivity of their chosen method of critical variables chosen? So it's a very extensive section, and I'm sure a lot of you would, it's written in a manner that most should be able to understand. I think it gives you an insight as to in the eyes of the designer, what they do, but it also shows some of the variables that they are using. And we've done a number of sensitivity analyses based on a number of properties of the concrete. For example, in here, we've got an effect of strength on the potential deflection. So you see on the bottom is the strength of the concrete, and on the vertical axis is the incremental deflection that would happen based on that. And so as you see, the stronger the concrete, the less deflection you would get, which makes sense because it's the stiffer the element is, the less impact it will see due to a superimposed load. But we also talk about the effect of the variables. So one of the ones is modulus elasticity, which is typically used from a designer's perspective. They will measure. They will not measure. Sorry, they will use the modulus as a function of the strength of the concrete and use that as a predictor. Trouble with that being is that the modulus of the concrete varies significantly based on the type of aggregate that's being used. So you could be using a weak limestone or a very hard metamorphic rock, and you're going to get completely different modulus properties in the order of 30 to 40% variation. So it's not the most accurate way to use, that being the F prime C. So there is a note in the 23.3 design code that when the impact of modulus or any of the other properties have an effect on the ultimate element that they're designing, they should measure the property that they're concerned about, rather than use it as a function of F'(C). So here's a sensitivity analysis based on, we've got different strength classes, and we've got an error variation from 0 being, or 1 being, you've got, it's exactly as the prediction value was, that was a function of F'(C). But then it gives the variations that one can expect due to the change in type of material that you're using. And it shows the impact on the deflection. And so you can see there's a wide array of values that can happen. And this is on the modulus of rupture is one of the other functions that you're looking at. So it can make a big difference. So lesson, you got to measure these properties in order to ensure that you're going to be able to at least control some of the elements and get something that is more realistic. There's also a section on, fairly extensive section on methods used to measure in situ values for strength, modulus of elasticity, modulus of rupture, and relative accuracy and benefits of each method. So this is also, and this is right up to speed, right up to date, and the latest and greatest means that we have to measure in situ strength. So it's again, it's an up-to-date best practices, and that's what we're providing here. The case studies presented at the ACI Denver sessions showing the results of efforts to control the impacts of design, construction, and quality control procedures used in a number of construction projects in North America. And here are some examples of different shoring techniques and reshoring techniques and stripping plans and how those affected the ultimate result in the slab measured after the fact. There's a section on, then at the end, of course, we have the reference documents that we've used, and there's a whole list of all the reference documents. This isn't complete. By the way, the annex that we're doing right now is in first. We've drafted it, and if you're aware of the CSA process that happens, you in subcommittee, which is, we have developed this standard. We have produced all the information, the data, the authoring. We've gone through an editorial review from our group. We then send it off to CSA, which I've done just recently. It's again reviewed by the editorial committee for CSA. That's right now under the control of Hannah Schell. And then they will make sure that everything makes sense, that the grammar is right, and that we've said things in the proper manner that we should. And then once that comes back from them, we send it out to the technical committee, main technical committee, some 35 members. And then it's balloted, where each one gets a chance to kick at the cat to give any rationale or reason for any technical adjustments or modifications or whatever, and then comes back to us. We do all those changes, and then once we finish those, then it goes off to public review. Again, that's a selected group of all kinds of people that are stakeholders in the standard, and they will give their comments as to for a new publication what they think should be done. We look at that, we will change some of the things if they're valid and whatever. And then it goes back to final draft to the TC to endorse the reviewed and audited and checked process and ready for publication. So that's the process. So we're just at the stage of editorial right now. NFC, I'm doing a presentation, essentially most of this, the same thing for National Floor Covering Association tomorrow also. I've had to add some extra stuff in there, but they've been very much involved with us in drafting this and making sure that we're dealing with all their concerns and issues and everything too. So they're a collective group representing across the country for the floor covering Association, and they're giving us their ideas on what their problems are and everything too. From a floor covering subcontractor's perspective, the present means of measurement using F numbers during the first week of a placement doesn't accommodate the needs of the geometric properties of the finished surface needed for the subsequent floor covering installation. A gap is present that needs to be closed, and I alluded to it earlier where I said we measure in F numbers and they measure with a straight edge. They don't measure the same thing, and the floor covering people cannot use an F number survey to determine whether they can install their floor. So there's a gap there. There's also a gap in the fact that any elevated slab is dynamic in nature, and as soon as you remove your shoring, it wants to move. Shrinkage and creep and incremental loading from construction, whatever else, all play a factor in what that rate and degree is. So you can't, so there's also nothing in the provisions in the standards right now, or in our documents, or in our construction contracts to accommodate this change from initially cast to a year later or 2 years later when the flooring guy comes in, that now he sees the effects of all these dynamic movements. So there's a move, a face right now, which by the way, we have architects on our group too, on presenting a cash allowance in Division 1 that would try to deal with the ability to be able to have a money set aside to be able to accommodate this dynamic movement and allow for a filler or a topping to go in place to set it back to the flatness that we need for the floor covering guide. Because of the present use of low VOC adhesives, a roughened surface to CSP 2 or 3 is required to adequately bonding between the floor covering and the base concrete. You see here the CSP 1, 2, 3, 4, 5, 6, so it's 2 to 3 is what they need, which is essentially a taking off of the top skin surface of the concrete to leave a pebbled look, which then has opened up the structure of the concrete to a degree where the low VOC adhesives have a tooth to grab to flow into and to provide the adhesive interface between the slab and the membrane material. As you're probably aware, use of curing compounds, steel finishing, etc., detract from the bonding characteristics of the adhesives used for these coverings. And that, in summary, is my talk. So it's a little bit of a description of what's going on with CSA, what this new annex is, and hopefully it gives you a bit of insight as to what it's going to try to do. But what we're going to try and do, obviously, is bring together all the individual groups and have some sort of a document where people can see what's going to happen in the future. Thank you.
Thanks, Lloyd. We have a couple questions here. The first one was asked fairly early on, but I'm going to ask it. This seems like a very thorough document. Can you explain a bit more in detail as to why this is needed? Are there major issues happening with elevated slabs, like deflections, etc.?
Yes. There are. And this is probably what's typically happened now. There is a significant amount of remedial that's always required because of the deflection and the movements. And up until now, this has always been a finger pointing exercise. So all of the general contractor will get in front of all the trades involved and point fingers and go, you screwed up, you screwed up, you did this, you did that, you did that. And then trying to arm twist because there's no money provided for what remediation is needed. And they're trying to somehow get it out of someone and blaming them for something that they've done. But when you look at the way we've developed this, it explains that there's all kinds of processes and incremental construction, a lot of timing and delays that happen due to the fact that the flooring never goes in place until a year or 2 years later after it was installed. So yeah, there is all kinds of things that are required to get it done. And we need to have this because the way we contract right now, again, as I was saying, is we have each individual group in their own silo has a responsibility at a particular point in time, but it doesn't deal with the duration of movements that happen over the year to 2 years before everything's done. So there's always a problem in that. So that's why we developed this. And I've been on this committee now for 30 some odd years. And we tried to deal with it with the code, you know, thou shalt do this and thou shalt do that. But we realized that there's huge gaps that way. And you can only say so much. And with something like this, which is a 50-page document, it gives the full understanding of what's happening as much as we can from all the design professionals that we've worked with. And it gives so we're doing right now in a couple of our projects out in Vancouver, we're implementing this whole process. And so we'll have a case study to see how that works. But yeah, so it's needed, and that's why I just continue to get problems and comments every time we did a new edition saying, well, you didn't talk about this or you didn't talk about that. And I realized that you can't because nothing is linked together properly as far as responsibility or what happened. It's a combination of all types of things.
And we have one more question, and then I'll, after you answer, I'll hand it off to Elaine to wrap things up. So the final question that was presented today, the presentation indicated that pre-camber was difficult to set up and curling was a significant issue. So what are the recommended practices to control curling?
Part of it's a lot of it is, quite frankly, a lot of it is environmental. What environmental conditions are imposed upon the element, the rate of drying, the surface that if I'm cast on metal deck, if I've got two sides exposed, the type of aggregates used, for example, the stiffness of the material with a more flexible aggregate, of course you can strain it more. The location of the reinforcing steel. If the reinforcing steel is not properly located, we're not going to see the engagement of the reinforcing steel to properly deal with the drying variations from the top of the slab to the bottom. And so that's a big element. So there's all kinds of different things that you need to look at. Also, the thing with the point cloud survey is we can measure at various increments in time to see the cause and effect of the exercises that we've undertaken to mitigate this effect. So, and if we can see that we can measure it on a regular basis, we can see the benefits. If we change something and we get less, then that's obviously giving us good feedback right away. Whereas otherwise, we don't have anything, and we're just hoping to figure it out. So there's a lot of things you can do, but then there's things you can't control. But it's with the measurement on incremental times, that's one of the key things that we can do to ensure that we can see the benefits of our strategy.
Are there any more questions, Danny, on online?
That settles it.
All right. Thanks, Lloyd. Much appreciate your time. Great presentation. And I'd like to thank everyone for attending. We had great 3 days worth of our fall concrete webinar series. The good news, we had over 135 registrations over the 3 days, which is great. We thank you for participating. Just to let you know, our next webinar will be in November. November 16th is the tentative date. We are working on a couple of presentations right now, so stay tuned to the website and your emails. We will be updating you very shortly. Our next AGM, which will be January the 18th, and we are planning to do an in-person meeting. We'll do our AGM and also have a presentation. We'll have someone there. We're working on a few topics right now. So hopefully we'll all be able to meet again. It's been over 2 years since we've been able to do an in-person meeting, so we are looking forward to seeing everyone there. And also the notice for election to the board of directors will be going out shortly. So if you are interested in serving on the board of the chapter, please send in your name and your bio to ACI-Ontario@gmail.com, and we will put your name on the ballot. And with that, we'd like to thank you once again for attending, and we will see you in November. Thanks again, Lloyd and Danny, for all your help with the 3 webinars this week. Bye for now.
Great. Bye now.